Well, greetings and salutations, everybody. I'm just going to do this real quick here. If you hear an annoying sound in the background, that just, well, that's my 3D printer because I'm in the process of making my own, well, it's going to be my first go at making my own equatorial mount for my camera. Anyway, I just wanted to run over this real quick. Somebody pointed out to me that Ranty came out with some new Isle of Man footage today. And I don't know why he did it in black and white, but he did it in black and white, so I'm just not going to argue with that. I really have no idea why you would do that, but it at least made it easier to do the contrasts. So, real quick, this is the image. Well, this is the composite that I did of his footage. This is Isle of Man. These are the turbines between a place called Nicky's Nook and Isle of Man. Funny little part here though is that see all these legs. Actually, hold on. Let me see if I can do this a little bit. No, that's not me. The quality wasn't all that hot in the hangout that I got it from. But you see all these legs? Remember all those legs that were not in your turbine footage from where'd you shoot that from? The last time I was doing some stuff of yours. Anyway, those are the legs of the turbines that you couldn't see. Why? Because of the curvature of the Earth. So let's just have some fun with that. Next thing, but that's just a side point. What's up, everybody? Alicia. And so here's all I'm going to knock out on this real quick. First of all, I seem to recall Riley, excuse me, Nathan saying that all of the Isle of Man stuff taken from Nicky's Nook was 80 miles away. Well, I'm sorry, it wasn't 80 miles away. As a matter of fact, the highest distance was 77 something, and that was the furthest distance away. Here's all the shots. Here's all the uh, what do you call it? Here's all the turbines. These are the turbines that he was shooting through. This is where he was observing from, and here's of course the different locations that I decided to point out just for this quick little review. Um, they're basically the highest points and the most noticeable peaks in the photograph. So here's what I did. Excuse me. Oh, and by the way, he says, oh yeah, the furthest one away was 124 kilometers. His viewer height was 214 meters, and that one was 473 meters, I think. So no, not everything was behind the curve. And also, the funny part is that the uh, uh, the mountain that I'm doing here, which is St. John's on the left side of the photograph, you'll see in a second, is the smallest and furthest away of the things that are in that image. So no, none of it's supposed to be behind the horizon, but you will notice some things that are missing here in a second. So there's another strike for you. Hold on a second. Now what I did was, like I said, I made that composite. That's Snaefell right there in the middle. Here's St. John's over here. Here's North Barul. Um, and there's a couple other different ones here in the middle. There's like three spots here. This peak, this bump, and this peak right here. This is the ridge behind North Barul. These right here, I don't know what the names of them were, and I couldn't find it. And honestly, I wasn't going to spend all night looking. So I gave everything names here. First thing I did was I got a line of measure from the peak of North Barul to Snaefell's Peak, and then you guys have seen me do this before. I copied that out and copied that out so I can get actually a grid to it to be able to find out exactly what it is I'm looking at. That's these right here. This guy here. This guy here. This guy here. This one's actually just a straight through to the other end of the island, which is also not 80 miles away. And then this one goes to North Barul, which is right there. So, and like I said, I gave everything names. Here's St. John's. That is the actual name. Then I'm calling this one UK left. I'm calling this the horseshoe. Then there's Snaefell. There's UK right. UK in this sense means unknown. And North Barul. By the way, right here, that's supposed to be Ramsey. Guess what? Ramsey's not in the picture. Go figure. But just to show you where I was calling these things, okay, there's a hilltop here. I'm calling that UK left. This one right here kind of makes a horseshoe. That's why I call the UK horseshoe. And then there's that other bump right there on the right side. And that's why I'm calling UK right. North Barul. Here's the last blue line on here before it even gets to Ramsey. But when it goes here, that's your last noticeable point of thing being any land being above the horizon. Same thing with this red line over here. Well, gee, there's a bunch of hills over here. Why don't we see them? Okay, so then of course, what did I do? Here's all the measurements that I used. These are all measurements provided by Google Earth as far as distance and altitude. Now, you can have whatever arguments you want about Google Earth. I really don't care. Furthest one away, like I said, was St. John's, and it's also just happens to be the shortest one of all of them. It's at 77.5 miles or 124 Ks, and it's 473 meters above sea level, which is what I had put into here. And if you notice, there's still 73. Well, there's still about 69 meters of mountain still visible. Now, if you want to make comparisons to that compared to these towers, have a lot of fun with that. I really don't care. But so yeah, no, I don't see any smokestacks, bud. And so here's what I did. I'm not going to go through the entire modeling process with you this time because of the fact that that takes an enormous amount of time. Plus, in my last silent movie, which actually wasn't so silent, I showed you how you can do this yourself. If you choose not to do it, I don't want to hear about your complaints about my method. So here's what I did. It's the same story as usual, only this time I had to go with, I did 4 tracks. Okay, it's actually 4 pieces of 111 Ks. The reason why is because everything was further than 111 Ks away, so I wanted to make sure I got a smooth bend. These are bent at 4 degrees because there are 4 segments in here. Okay, and then basically, and I got one as a flat and one as a curve. I did not name the cameras, my bad. And I got them at the required height that they're supposed to be. And here's the analogs. If you look at it from the right side, or excuse me, from the front here, okay, you will notice they are all identical distances away on both cameras. Just one is across a curved surface, one is not. Camera 1 is the curved camera. This is what the results look like, okay? And I will do a render for that. This is what the results look like, okay? Now, camera 2 being the flat camera, this is what the results look like. I was a little bit more zoomed in here, but that doesn't make any difference. All it is just magnified. And as you notice, everything here is below, everything here has a portion of it that is below the horizon, but in front of the horizon across a plane. Okay, so any discussions about what's going on at the horizon, you have to also talk about what's going on below the horizon line, which you're not going to talk about. I'm not expecting you to. But nevertheless, because across the plane from 214 meters up, a portion of this would be below the horizon line. Period. That's just what that is. Okay. Um, do, 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 do. And then what I did was I turned around and I did the comparisons. Now, first one I did, this is the flat comparison. Now, like I said, this is the horizon line. It's actually up about 1 tick too high. Hold on. Right about there. Now, see, format picture. All I'm going to do is change the opacity so you can see the image. Oops. So you can see the image I'm dealing with. Okay, got that. This little part off here, that little bit of black edge right there, that's just the edge of the track that I have in the 3D camera. You can see the rest of it's filled in just fine. Okay, now what you don't see here, now I measured it up to the height of Snaefell versus the horizon because that is one that's the highest peak. So I made sure I did that. However, from left to right are also left to right in here. Okay, so the red one is St. John's. Okay, about twice as high. Okay, then we got UK left, which is the orange one, bit too high. Okay, you got the horseshoe bump. That's this guy right here. Bit too high. Snaefell looks right on because Snaefell is what I'm using to measure between, again, the horizon and the peak. And then UK right actually works out quite well, and so does North Barul because they are both a lot closer. And so that's just what that is. Now, on the this here is the curve image. Hold on a second here. I want to make sure that I show you the where I lined it up at. Oops. Okay, there's the picture. Okay, you saw it just a second ago. Now, St. John's came off a little bit. I don't know why, but it's off a little bit. All the rest of them, this is UK left, works out just fine. Horseshoe bump, right on it. I use Snaefell as the measuring tool, and then what do you call it? UK right is right on it, and North Barul is right on it. Nothing is even close to being far off. Like I said, the only one that's a little bit off here is St. John's, and that's only because I think, honestly, that it might have something to do with this turbine in my view here, but I'm not positive on that, and I'm not looking to be quoted on that either. Okay, but that's the only one that's just off by a little bit. Okay, so basically, Ranty went out, took some footage, and it works out just fine to the measurements of the globe. And yeah, I don't know what else to tell you on that. I'm sure they'll come up with some excuses, or like everything else they do, when you show them something, they run off to a different subject. Um, this is just how this works. I can even zoom in more on this. It doesn't matter. Camera one, sorry, camera one. There. Yeah, I'm zoomed out a little bit. Okay, zooming in, zooming out doesn't do any relationship change between the height of the horizon, or the between the horizon and the height of the objects. It doesn't do that. So anybody would have that argument. I really don't care. So, ladies and gents, I wanted to make that as quick as possible. And like I said, if you want to go ahead and model this stuff out yourself, I showed I did a how-to on that the other day on Silent Movie. It's got an image like this, similar to this as the thumbnail, and you guys can download that software for free and do the exact same method that I used here and check it out for yourself. So Oakley lied about the distance to the Isle of Man. He lied about the fact that he says a curvature calculator, which he has some big, long, stupid name for. A curvature calculator, in this case, Metabunk, um, does not say that it's below the horizon. In fact, none of it is below the horizon, with the exception of when it goes out beyond the edges of what he has in the photograph, because that, let me go ahead and do this here. If you want to see that, this right here, there's still more land and hills over here. But yet, for some reason, on this absolutely beautiful day, or at least weather conditions were great for a photo, uh, it goes off below the horizon. There's no, you can't even make the refraction argument at that point as far as, distortions on the horizon. In fact, you guys kind of praised it for that. And on this side over here, goes down below the horizon. Okay, this right here, if it were a little bit clearer, this is that kind of nose-looking thing that we always like to point out on the older Isle of Man footage. So yeah, that's all I got. Ramsey's supposed to be here, and remember, no Ramsey, no flat Earth. Isn't that right, Riley? So, ladies and gents, that's all I had. I think I did it in record time this time. So, um, I hope y'all enjoyed this. And like I said, look at one of my previous videos on exactly how to model this stuff out yourself. Wow, that looks kind of wacky. How to model this stuff out yourself, because you can do it yourself. You can do the measurements yourself. and you can check their you can verify the claims. Okay, instead of just listening to somebody just say that stuff is supposed to be behind the thing, behind the curvature. Check for the left to right curvature. Okay, well, the left to right curvature in that particular picture. Now, I had done a measurement just at this point, even though the horizon is well before this point, and between these two red lines is 2.5, so that's 7.5 miles. Let's see, or was that miles or kilometers? Hold on, make sure I'm right on that. Properties. What was that line measurement? 12 kilometers. Yeah, I think I did that in miles. Yeah, 7.5 miles. Okay, so we'll just do kilometers just for a joke. Okay, so 12 kilometers. Well, that's pretty easy to round off. That is seeing that 1 degree of curvature would be 111 kilometers. This would be 1/10 of that. So 1/10 of a degree of curvature, which you would not notice hardly at all. 1/10 of a degree of curvature in the entire breadth of that image that he has in his presentation. This right here, this would be entirely 1/10 of a degree of curvature from left to right. And that would only actually be noticeable if it was in a single shot. But that's not even in a single shot. And his height's not really enough to see that anyway. And plus, the horizon's a lot closer. What's the distance on the horizon on that? Let's see. Oh, the horizon's 52 kilometers away, so it's half that distance. So it's even less curvature than what I just said. Okay? So, ladies and gents, I appreciate you stopping by. Ranty, thanks again for proving the globe. You're doing a great job for us, man. Just keep it up, man. And sometime soon I'll get the air pressure video done as well, and you guys can enjoy that. So, Gary, sorry you didn't miss much. It's all done. So, ladies and gents, I hope you all have a nice night.